That would be the easiest way to do things, for sure. You can even set it up before the midterm, right? So you can set it up now if you want to. And yeah, make a project. Maybe even well, don't make a class yet because you don't know what class I've asked you to create. But yeah, just get it set up now and you'll be all set to go for the midterm. All right. We left off on this slide at the end of the last lecture. So we were just finished talking about some relatively simple methods in our 3 classes. Now I want to go back and revisit the constructors. You're allowed to have multiple constructors in a class, but the signatures of the constructors must be unique. So in other words, now remember what the signature of a method is, right? So the signature of a method is the name of the method, followed by the types in the parameter list. Well, the signature of the constructor is the name of the constructor, followed by the types in its parameter list. Now, constructors all have the same name, right? It's always the name of the class. So that means that they must have, if you have multiple constructors, they need unique lists of parameter types. Right. Now, why do you create multiple constructors? Because it makes your class easier to use. Right. For the point 2 class, it would be nice if you had a constructor where the user could set the x and y coordinates when they create the point. So for example, you can add such a constructor right here. I think we already looked at this because this is an example where you have to use this x. Okay, so the no argument constructor not shown, right? But you can look at it, go back a few slides or look at the source code in Eclipse. Right, we've got our fields x and y. Here we've got a constructor. It's got 2 parameters also called x and y. Right, and this constructor should set the fields x and y so that they're equal to the parameters x and y. Now, because the parameters have the same name as the fields, right, you can't write x equals x. You have to write this x equals x. Right, so remember that this dot x means the field x inside the constructor. Right, this dot y means the field y in the constructor. Yeah, so there's your that's an example of a simple constructor that has parameters. Okay, so how does this thing work when you call it? So it's the same thing as before, right? When you write this line of code, a variable p appears somewhere in memory. So there it is. New runs. Well, let's go step by step, I guess. New runs. So an object gets created in memory, right? Remember, the object gets created by copying the class, right? So somewhere our point 2 object appears. Right? It's uninitialized. So it's fields x and y. For our purposes, they have no value. I'm pretty sure they actually these fields get initialized to 0 at this point in time, but whatever, it's fine. Let's just assume they're not initialized. So new runs gives me my uninitialized object. New calls the constructor. So this time it's the second constructor that's being called. Right now, when this constructor runs, right, it runs somewhere in memory. It gets a variable called this, right? And remember, the address of the value of this is the address of the object that was created by new. Sorry, let me turn off my camera so it doesn't show up on my picture doesn't show up on the video. And it has 2 parameters, x and y, right? So these parameters, x and y, those are the parameters. And because the constructor was called with the values -1 and 1.5, right? The value x and y are set to -1 and 1.5. Now the constructor runs, and the constructor says this dot x equals x and this dot y equals y. Right? So what's this dot x? Well, there's this. Right? So we follow the reference to the object. Right? Dot x is that field there. Equals x means equals that value of x here. Right? So that's -1. This dot y equals y. Right? Again, follow this to the object up here. Dot y means the field here. Equals y means that value there. So the fields of the object get initialized to -1, 1.5. The constructor then finishes running, which allows new to finish running, right? And when new finishes running, it returns the address of the newly created object. So the value of P is the address of the object that was created. So it works the exact same way as the no argument constructor, except this particular constructor has some parameters. Okay, so the technical term for when a parameter has the same name as a field is called shadowing, right? So we say that the parameter shadows the field in this example. In this case, both parameters shadow a field in the class point2, right? So inside this constructor, the name x means the parameter x. The name y means the parameter y. So sometimes you'll see this called hiding, right? So in other words, the parameter hides the field, which is why you have to write this dot x to get to the field. And you have to write this dot y to get to the field named y. So in this particular example, you have to use this. If your parameters do not shadow the fields, then you can just use the field names on their own, right, without using this. I guess if you want to be safe and you when you mean to access a field, you can always use this in front of the field name, right? And you'll never go wrong, right? It'll never be a mistake. All right, custom constructors. So that that constructor doesn't have a particular name, right? It's just a constructor. So adding these quote unquote custom constructors, it makes it easier for people to use your class, right? So instead of writing, sorry, let me get rid of that line, that's annoying. So instead of writing point2 equals new point2, right? So that makes the point 0, 0. And then setting the coordinates of the point to -1, 1.5. Right. So instead of writing that, now people who use your class can just write that. Right. So in other words, they can initialize the coordinates of the point, or they can set the coordinates of the created point instead of making a default point and then having to set the coordinates. Right. So for the point2 class, it saves you a little bit of code, or it saves your users a little bit of code. For other classes, for more complicated classes, it could save your users many lines of code, right? If there's many fields that have to be changed. There is a second kind of special constructor that has its own name. So there's a constructor called the Copy Constructor, and the Copy Constructor lets you copy another object of the same type. So the Copy Constructor has a single parameter, and that parameter type is always the name of the class. Right? So in other words, the point2 Copy Constructor has one parameter of type point2. And so this type of constructor lets you initialize the newly created point by copying the state of another point. Right? So I usually call the parameter other. It might be called something else, like so other, I mean, if you're writing your own class, you might choose to call it something else. But calling it other makes it pretty clear that you're copying another object. How do you write this? Well, for point2, it's easy, right? I just need to copy the x coordinate of that point, and I need to copy the y coordinate of that point. So this x equals other x, and this y equals other y. Inside the point2 class, you are allowed to access the fields, the private fields of another point2 object. Right? So any point2 object, you can get to its private fields and methods inside the point2 class. Right? So there's nothing special about this point as far as the class is concerned. Right? It's just another point2 object. So even though x and y are private, you can still access the fields x and y. I guess that's all I want to say about that, right? So normally in a copy constructor, it's just the way you implement it is you copy each field of the other object. And again, why do you do this? It's because it lets you it lets people who are using your class more easily use your class. Right. So instead of making a default point, whose coordinates are 0, 0, and then using set and get to get the coordinates of a copy to, so instead of and then using set to set the coordinates of the point to equal another point, right? And to get the coordinates of the other point, you now have to call x and y to get the coordinates of the x and point of the other point. You can just use the copy constructor. So here's an example of a little program that uses the copy constructor. I'd make a point -1, 1.5, and then print the point. Right, so you get -1, 1.5 here. I'm then going to copy the point P and call it Q. Right, so Q is an independent copy of a point. Its coordinates are the same as P. Right, so when I print Q, I also get -1 and 1.5. Right, now remember, this is a new point, right? So these are two distinct point objects. So if I change the coordinates of P, the coordinates of Q do not change. Right, so in other words, if I set the coordinates of P to 99 and 44 and then print P, right, coordinates of the point that are referenced by P does in fact change, but the coordinates of Q do not change. Right, so you get two independent objects. It's just that when you create Q, it happens to be equal to P, right? So its coordinates are the same. All right, so let me pop open Eclipse for a second. Let's take a look at these three constructors that we have. Too much space here. All right, so there's our no argument constructor, right? If we look at the lines of code in the no argument constructor, it's this x equals something and this y equals something. Here's our second constructor. And again, when we look at the body of the constructor, it's this x equals something and this y equals something. Copy constructor, right? This x equals something, this y equals something. Right? So in other words, the bodies of the constructor, they're all almost identical. Right? All they do is set the values of x and y. So in other words, the code that's inside all of our constructors, it's almost duplicated. Right? So in other words, it's almost identical in all three constructors. And you should have been told in CISC 121, right? So whenever you do something over and over and over again, right, you should create a function in Python, right, that does the thing that you're repeating yourself over and over and over again. And then just call the function instead of repeating yourself over and over and over again. Right? Well, the same is true in Java. So if your constructors are all doing more or less the same thing, it would be nice if there was some way to just use one constructor. Right? So I want one constructor to do all of the work, and I want the other constructors to call that one constructor. Right? So when we look at our constructors, right, we ask ourselves, well, if I want to do this, what's the most general constructor here? Right. So in other words, what's the constructor that I can use to implement the other two constructors? Right. Well, this second one here, that lets me pick what I want to set x and y to. So that looks like the most general one. Right. Because I can use this one to make the point 0, 0 just by passing in 0, 0. Right. And I can implement this one by calling this constructor and passing in other x and other y. So it looks like I could use this constructor to do all of the work if I can somehow call that constructor from here and call that constructor from here. So it turns out there's a way to do that in Java because so first of all, it turns out constructors all do the same thing in general. Right? The job of a constructor is to initialize the state of the class of an object. Right? So there's a pretty high likelihood that the bodies of the constructor have a lot of similarity. So the designers of the language put in a mechanism that lets one constructor call another constructor, right? And that mechanism is called constructor chaining. So when a constructor calls another constructor to do all of the work for the initialization or to do part of the work for the initialization, that's called constructor chaining. To call a constructor in the same class from another constructor, you use the this keyword, which is unfortunate because we spent a lot of time saying that this means the object, this inside of the constructor means the constructor that's being, means the object that's being initialized, right? Is a reference to the object being initialized. Now I'm telling you that it also means something else, right? The other thing that it means is you're calling another constructor, right? If you do this, right, so if you decide to call another constructor, then it has to happen, right? It must occur on the first line of the constructor body. You're not allowed to do it anywhere else, right? You're not allowed to do it in a method. You're not allowed to do it outside of a constructor. And when you do it in a constructor, it has to happen on the first line of that constructor. Okay. So what it looks like is as follows. There's my constructor that I want to use to do all of the work. In the no argument constructor, I would like to call this constructor. So the way you do it is you write this round bracket and then pass in the arguments to the second constructor. Right. So in this case, I have to pass in 0 and 0. So we write this round bracket 0, 0. That causes this constructor to be run, right? So when someone calls this constructor, this line of code runs, which causes this constructor to run. And this constructor finishes, which allows this constructor to finish, and then new can finish running. Second constructor, right? I want to pass in other x and other y to the second constructor. So we write this round bracket other x comma other y, right? That causes, oh, so when someone uses this constructor, that line causes this constructor to run. And when this constructor runs, it sets this x to other x and sets this y to other y. You are allowed to have code after the constructor chain, right? So when this constructor returns back to the first constructor, you are allowed to insert extra code here. Similarly, when this constructor calls this one and then this one finishes, it comes back to here, and you are allowed to have extra code here. You cannot have any code here. You cannot have any code here. How does it know to use the second and not the other constructor? So it matches the, right. So what the compiler does is it says what is the signature of the constructor that's being called, right? So the signature of the constructor that's being called is double double, right? So the search is the class for the constructor that has two parameters, double and double. Same way that methods work in Java, right? The compiler searches for the method whose signature most closely matches the argument types. It's actually very, the precise mechanism for matching constructor and method calls, it turns out to be, the algorithm is very complicated. But for our purposes, you just look for the one that matches the most closely. If you were to put in a comments are fine. So comments, the compiler ignores. So it's as though the compiler treats it as if they were not even there. So you can insert a comment here if you like, no problem. And so that's the constructor chain. Now, in this particular case, we're not saving a lot of work. We're saving exactly one line of code here and one line of code here. So you're not saving it's not really buying you very much here. It's not until you have to initialize, it's not until you implement a class where there are many fields or where it's complicated to initialize one of the fields, where constructor chaining saves you a lot of work. In this particular case, it's pretty debatable whether it's worth it, but it's a simple example to illustrate the principle. The counter class is even easier, right? So the counter only has one field. Right? So I can insert a second constructor. Where does it say? Right. So I can insert another constructor that lets the user set the counter to some specified positive value instead of 0. Right. And we can also add a copy constructor to the counter class. If you use chaining, right, then we can rewrite our no argument constructor to call the second constructor. So our second constructor is going to set the value of the counter to that value there. Here's our second constructor. It's going to set the value of the counter to that. So on the last line of the constructor body is this value equals value. The counter class is actually, it turns out to be a very good example for teaching purposes because it's super simple, right? It's very easy to understand. And two, it's probably the simplest example of a class that has something called a class invariant. Right? So, sorry, let me just look at the source code of counter. Okay, so our counter class, oops, sorry, that's a slightly more sophisticated version of counter. Okay, so our counter class says, right, that it represents a device used to incrementally count upwards from 0 up to integer max value. Right. So what this is telling you is that the value of the counter is always lies between those two values inclusive, right? So the value of the counter is at least 0 and no more than integer max value, right? So that's a promise that the class is making to anybody who uses the class. Right? So that's an example of what's called a class invariant, right? That value is always between or equal to one of those two values, right? So when you are implementing the counter class, you have to make sure, right? It's your responsibility to make sure that the value is always between those two values, right? And so what does that mean for our constructor? Well, if somebody's going to pass in a value, right, then we have to make sure not to write this value equals value, whatever that thing is less than 0, right? Because in that case, we end up with a counter whose value is not between 0 and integer max value, right? So in other words, we're breaking the promise made by the class, right? Or I guess more precisely, the class invariant is no longer true. So when you have a constructor that initializes the state of an object using some user specified value, it turns out that in a lot of cases, you have to validate the input value. Here we have to test, is the value less than 0? If it's not, I can't do anything with that value, right? Or I can't set the value of the counter to that value. So I'm going to decide to throw an exception instead, right? To indicate that the caller is using this constructor incorrectly. Value is less than 0, throw a new exception. One of the common errors you see here for people who are new to Java, right, is they don't validate the parameter. Instead, they write, if this value is less than 0, throw a new legal argument exception, right? And that will never work. Well, that never throws an exception, right? Because when this constructor starts running, this dot value is 0. So if you write this value, if this value is less than 0, that's never true. Remember, you're validating the parameter. You're not validating the field. Other common error you see is that people do the validation, new programmers do the validation last instead of doing it first. Instead, they put this value equals value up here. Let me just go to Eclipse and do that. Where is, oh, sorry, that's why the other one's open. The basic version of counter doesn't have that second constructor. So instead, new programmers sometimes write that. There we go. Right. Now this isn't correct either. Right. So the problem with this is, if someone passes in a negative value, right, say -1, then that line of code sets the value of the counter to -1. So in other words, the state of the counter becomes initialized, right? And then the exception is thrown, which is not good, right? So it's possible then to get an incorrectly constructed object. So you want to validate first and then set your fields. So validation happens first. Initialization happens second. And then finally, you can implement the copy constructor without any using constructor chaining. Right. So I'm going to call the second constructor, this time passing in the value of the other counter. Right. And again, you're allowed to access the value field even though it's private. That thing there is a counter object. And inside the counter class, you're allowed to use the private features of any counter. There's one disadvantage to constructor chaining in this example, right? Well, I guess there's a few disadvantages here. It's not really disadvantage. Number one, you don't save any lines of code, right? This the old constructor was this value equals 0. The copy constructor, you could just write this dot value equals other dot value, right? So constructor chaining doesn't help in this case. The problem with constructor chaining is here, right? So when you make a counter whose value is 0, we know that 0 is a legal value for the field, right? So we don't have to check is the value less than 0, right? Given another counter and the rest of the counter class is implemented correctly, and the value of that other counter is always between 0 and integer max value. So we don't have to validate this other counter either. When we use constructor chaining, right, we always validate the incoming value, right? So you're always paying a cost of this validation if you use constructor chaining, right? There's an unnecessary validation here, and there's an unnecessary validation here. So there is, now the validation is not a big deal, right? That's just one if statement. So in almost every circumstance, that's not going to matter, right? That line of code will run very quickly, right? You won't be able to tell the difference that it's actually there. But it could be, but you are paying an unnecessary cost. So there are some disadvantages to doing constructor chaining, right? Normally, the disadvantages outweigh the advantages when you have a class that has many fields. So that's everything you need to know about constructors, or that's all the everything you know about the basics for constructors, right? Of course, the constructors, these are all very simple, right? Because you have a field and we're just setting the value of the field to some straightforward value, right? We don't have to do any calculation to compute the value of the field. It's of course, you can create a class where initializing the fields becomes more complicated to do, right? So it's not always this blah equals blah or this blah equals blah, right? Sometimes you have to write some extra code to do some initialization. But you'll have a chance to practice that on the next assignment, which will come out shortly. Okay, so moving on to the next lecture. So this is the next set of lecture slides. It's classes 2. Hello, there we go. I guess now is a good time to start talking about documenting Java code. So of course, if inside the body of a method or constructor, it's sometimes useful to have a small amount of documentation so that other people who are reading your code, or when you come back to look at your code after some period of time, right, whether it's days or weeks or months or years, you can understand what's going on inside of a complicated method, right? But perhaps what's even more important is the documentation that tells people who are using the class exactly what is this method supposed to do, right? So what is the contract of this method, right? What are the parameters for? What value does it return? what is the purpose of this method or constructor. Now, that's a problem that has existed as long as computers have been around. So documenting code was not a new idea when the Java language was invented, right? Some 30 years ago, roughly now. One of the big innovations that Java had was that it was the first major language to embed documentation in the code and then provide a tool that can extract that documentation into readable electronic documents, right, into web pages. So all documentation for a Java class, you just look at it with a web browser. Right? So when you want to know how string works, you just Google Java string, and it pops up some web page that gives you the documentation for the string class. That tool that reads a class and extracts the documentation is called Javadoc. So every time you download a Java development kit, you also get the Javadoc tool as part of that development kit. The way Javadoc works is it reads your source code and it looks for these things called doc comments. A doc comment in Java starts with /**, right, and ends with //, right? So it looks like a multi-line comment. It's just that the opening of the comment has an extra star in it. Doc comments are written in a subset of HTML. It's not the full. You don't get all of the HTML tags, right? So you don't get the full HTML spec for your Javadoc. You can use a pretty limited subset of the regular HTML tags. Now, if you don't know what HTML is, that's hypertext markup language. That's one of the main languages that you can use to write a web page. So it's got HTML uses these things that look like tags. They're called tags. They look like that, right? So less than, something, greater than. To denote, what is HTML called? To note, I guess, things inside of the document, right? So paragraphs in HTML start with the tag P, right? Hyperlinks start with the tag A, and so on and so forth. If you don't know HTML, don't worry about it. It's actually not a problem. Because you can write most of your documentation in just plain English. So when you write your Javadoc comment, it always starts with a description. Right? The first sentence of your description gets copied into the summary section of the thing that you're documenting. So I'll show you an example. I'll show you examples of that shortly. One of the limitations with Javadoc is all of your documentation goes into one of these things, right? So when you're documenting a method, you only get one of these comments to document the entire method, right? So when you document the class, you only get one of these. When you document a constructor, you only get one of these for each constructor. So if you have very long documentation that you want to split up into paragraphs, that's when you have to use the HTML paragraph tag to split things up. If you just put in blank lines, the Javadoc tool just deletes the blank lines. So that's the first part. So you write a description of whatever it is you're trying to document. And then if you're documenting a constructor or a method, you can document the parameters using @param. You can document the return value using @return. You can document any exceptions that might be thrown using @throws. So this thing, Javadoc considers to be special. So denotes the beginning of what's called a tag in Javadoc. It's easier just to look at examples of this to see how this works. So every class should have a comment that describes the purpose of the class, right? Now, what the comment should not do, right? It should not tell people how the class is implemented, right? So it shouldn't say this class has got fields, blah, blah, and blah, right? It shouldn't say things like this class uses an array list internally to do blah, 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 right? So you're not supposed to describe how the class is implemented, right? You're trying to describe what does this class do, right? So what's the purpose of this class? So for the point2 class, there's a comment, a Javadoc comment that describes the purpose of the point2 class. So the point2, the point2 class is just a two-dimensional point having real coordinates, right? If you look at the standard library documentation, typically the description of the classes is very thorough. I need a web browser, but I don't want to pop up my mail. Sorry, a second. This one's fine. All right. So for example, if you look at the string class documentation, so whoever wrote the string class documentation, right, they went through a fair bit of trouble to describe the purpose of the string class, right? In the description, you're also going to include things. You're also going to include any information that's important to users, right? So for example, it tells you that strings in Java are represented using Unicode, right? And that's probably pretty important if someone is looking to write a multi-language Java application, right? They're going to want to use a class that can, they're going to want to use a string class where you're not limited to just English, for example, right? So that's kind of important for people to know. Many of the Java classes have very long very long descriptions of what the purpose of the class is. Oops, where did that go? Back to here. Okay. Now, when you run the Javadoc tool on this class, this comment here, that's the thing that shows up here, right? So it's the it's the documentation that shows up at the beginning of your documentation. If you have fields that are public, then you should also comment those with a Javadoc comment. Right? If you have private fields, you normally don't create a Javadoc comment for them. Right? You can still comment them. It's just that when you run the Javadoc tool, the tool does not produce the documentation for private features. You can change the way it works, but normally the Javadoc tool only creates the documentation for the public features in the class. So if you have a public field, you should comment that, right? Because a public field is something that users of the class are meant to use, right? That's why you made it public, right? So you should describe what is the purpose of that field. Again, the first sentence of your comment, that's the thing that appears in the field summary section of the generated documentation. Now, our point2 class doesn't have any public fields, but the math class does. So the Java lang.math, if you Googled for the source code, you would find something that looks like this. So the class math has a constant field called big E. That's Euler's number. It's got a constant field called pi, right? That's the mathematical value of pi. And it's got a Javadoc comment that looks like that. If you were to run the Javadoc tool on this piece of code here, you end up with this section. You get a description of the fields, right? And the first sentence. By sentence, it's the thing that ends with a period, right? So the first sentence appears here, right? So the summary section, it's only one sentence that appears. But sorry, I should show you something about the fields. Now, when you're reading Javadoc, fields are a bit funny. Okay, so when you look at a field documentation, the value, right? These are constants. That's why they're public. They're also static. right? So public static, they're also final. When you look at the Javadoc for this, it doesn't tell you what the value of E or pi is. Even if you click on one of these, it still doesn't tell you, right? So when you go down to the detailed description of the field, right? So this is called the field detail section. When you look at the detailed documentation, it still doesn't tell you what the value is. So Javadoc's a bit funny. You have to click on this thing here, and that takes you to a separate page where the value of all of the constants, where the value of all of the, the value of all of the fields are shown for all of the classes in the package. But I think maybe it's not just the package. Just a second here. Is it? Oh, it's not just the package. It's everything. Okay. Right. So here you can now find the value, its actual value. Right. So you have to go through a little bit of work to get to the value of the field. If you click here, it goes back to the class where you came from. Every public constructor should also have a Javadoc comment that describes the purpose of the constructor. I'm just going to go to the next slide. All right, so here's the documentation for our no argument constructor. So initializes the coordinates of the point to 0, 0. Now this at code thing is a bit funny. Right? So brace, right? At code, base, and then some stuff. So this tells the Javadoc tool to format whatever's here using a monospaced font, right? So a typewriter or a computer style font. So when you generate the documentation for this, it looks like, have it, it's here somewhere, just a second here. There, right? So when you generate the documentation for that thing that's inside, that's denoted by an at code tag, it gets formatted like that. So normally when you refer to a parameter, like X or Y, you put that in an at code tag to set it off from the rest of the text, right? So it looks distinct from the rest of the English text. Now that's what you would do in a professional setting anyway, right? So people who write code for a living, or people that write documentation for a living would do this sort of thing. In this course, if you're asked to document something, you don't have to do this, right? So if you want to say it's 0.00, just write. You can just write round bracket 0, 0. Right? Doing this sort of thing takes up a surprising amount of time, and also requires a surprising amount of attention to detail. So I don't really care if you do that in this course. If you want to, by all means, go ahead, but you don't have to do that. If your constructor or method has parameters, then you should describe the purpose of the parameters after you describe the constructor or method. So this always goes at the end of your Javadoc comment, or towards the end of the Javadoc comment. So this constructor here has two parameters, X and Y. So we should document what X and Y are. So the way you document them is after the description, right? At param, name of the parameter, a short point form description of the parameter. Y, at param, space, name of the parameter, space, point form description of what the parameter is for. You need to put in detailed description of the parameter. That should go into the description of the constructor. Go here. So this should not be a very, very long. This should not go on for lines and lines and lines. Eclipse will generate this stuff here for you. So let me show that, and then we'll end the lecture. Where is Eclipse? Okay, point 2. Oh, I did it here. Okay, so I'm going to delete the Javadoc comment. So if I want to generate the Javadoc comment for this constructor, just click on the constructor header. Go up to your source menu, and then source, and then choose generate element comment. Sorry, it's probably a little small. generate element comment. Click, and it will produce the skeleton of your comment for you. Right. This is nice because you don't have to remember to type in the name of the parameter here. Right. Then just go ahead and edit it. Right. So this is the x coordinate of this point, and that's going to be the same thing. Y coordinate of this point, and whoa, sorry. And up here you would put in a description like that. Right, so Eclipse will do that all. Will do all of that for you. I should show you something else. If you decide later on you want to change the name of this parameter, right? You can highlight the parameter and right-click, or go to the source menu. Sorry, go to the. Is it the source menu? Might be the edit menu, and go refactor, and then rename, and then change the name. So new X. Press enter. Sorry, just type new X and then press enter, and then it will change the parameter name for you here. It also changes any use of the parameter inside the constructor or method for you. Right, so don't do it by hand because you're inevitably going to forget to do something. All right, so I'm actually a little bit over time. Does anybody have any questions about the lecture today? I guess, or of the midterm? Okay, I'm not seeing any questions. Thank you, everybody, for coming out at 8:30 in the morning. And I guess you have your midterm tomorrow. No, there is